Hi friends, today we are going to learn a new topic that is basic introduction of high voltage engineering, so watch the full video to get basic concept related to high voltage engineering. So let's start this video. The presentation outline contains these topics: first of all, basic introduction of high voltage engineering, then the classification of high voltage, then terms used in HVE, then the processes used in HVE, then the applications of all types of high voltage engineering, and at the last conclusion is given. The basic introduction is that high voltage engineering is also called as electrical insulation engineering. It is defined as high voltage engineering is the study of electrical insulation when are subjected to high voltages. High voltage means voltages in kV or 1000 volts. High voltage engineering is mostly used for larger distance to overcome power losses. The typical ranges of high voltages are listed below. First is HV, that is high voltages or HT high tension. Second one is EHV, that is extra high voltages or HT extra high tension, and third one is ultra high voltages or HT ultra high tension. The high voltage is classified as: first one is high voltage alternating current, that is HVAC. Second one is high voltage direct current, that is HVDC, and the last one is high impulse voltage, that is lightning and switching. Figures of all these types are given below. Introduction of HVAC is given as nowadays the electrical power is generated, transmitted and distributed in terms of AC voltages due to its advantages that it can be stepped up or stepped down at the desired level by using transformer, hence it become economical. An alternating current changes its magnitude and direction many times in second during its one cycle. Introduction of HVDC is given as the DC does not change its direction many times in a sec, just like AC changes. Therefore it is unidirectional, or it has got the uniform direction, hence it has no frequency. Now trend is going towards the HVDC, where the electric power is generated as AC, then is stepped up to higher voltages, then mercury arc rectifier is used to convert AC into DC, such that transmission is carried as DC, then thyrotron is used to convert DC back into AC, then again power is utilized as AC. Introduction of high voltage impulse is given as high voltage impulses are also called the transient, and these are produced due to internal switching surges or external lightning surges. An impulse means the unidirectional voltages rising suddenly to peak value and then failing to zero. Different terms used in HVE are states of matter, electron collision, and different energy diagram. So first of all, states of matter can be defined as an atom in matter may form any of three possible states. First is normal state, is neutral or unexcited state, then excited state is one electron from inner orbit is forced into the outer, then ionized state is electron is either completely removed or added to the atom, thus the resultant charges will not be zero. Electron collision can be defined as it is an interaction between the electron and neutral atom of gas dielectric. Electron collision in gas may occur in any of two ways. First is elastic collision. It means a collision in which there is no net loss in kinetic energy. Second one is inelastic collision. It means it occurs when some amount of kinetic energy is lost. Energy diagram can be defined as a diagram which is used to represent the different energy level of different solids. The valence band is the lowest band of energy and conduction band is the highest energy band, and forbidden gap is the gap between two bands, and Fermi level is minimum energy level for an electron to reach the conduction band. The processes used in high voltage engineering are ionization and deionization or decay. The ionization process can be further classified in different types such as primary ionization, secondary ionization, and ionization by cathode processes. Applications of different types of HVE are given below. The use of HVDC can be an electrostatic precipitator, HVDC transmission line, electrostatic paints and cement industries. The use of HVAC can be in X-rays application, power transmission, and in military application. The use of impulse voltage can be in testing of transformers, HV cables, and in switchgear, and many more. So in a nutshell, we can say the power systems engineer is interested in high voltages primarily for power transmission, and secondly for testing of his equipment used in power transmission, to confirm the reliability and efficiency of the equipment or products. The commercially HV generators are applied in routine testing laboratories for testing equipment such as transformers, bushings, cables, capacitors, and switchgear. When dealing with high voltages, it is important to understand the health and safety aspects, and further precautions must be taken, as this is an important feature when dealing with high voltage applications. Failure to do so, it can result to serious injuries and death. Thank you so much for watching this video. If you like my video, so please share and do subscribe this YouTube channel Engineering Knowledge.